is what we just talked about how at the x-intercept the y-coordinate is 0, and at the y-intercept the x-coordinate is 0 to help us with this. So this says use intercepts to graph, and I just want to mention something to you. I've heard you guys, I mean, we talked about it a second ago, heard you guys talk about slope-intercept form, right? I hear like mx plus b thrown out there, things like that. I just want to let you guys know. You're supposed to do Pop Goes the Weasel. I like that tune better. That's the quadratic formula. So, hey guys, I don't know why she just did that, but now we're off track a little bit. So, guys, important point. I'll wait until it's calm so you can all actually hear this. This says use intercepts to graph. So, if you were to graph this correctly but you use slope-intercept form, you're really not following instructions, correct? So please, please, please don't look at this and say, oh, that's cool and everything, but I'll just use slope-intercept form. We'll use that too sometimes, but make sure that you know how to do this as well. Okay, so here's how this works. I'm going to try to find my two intercepts because how many points do I need to draw a line? Only 2. So if I can find the x-intercept and I can find the y-intercept, then I've got my 2 points, I've got my line. So here's how I would do this. I'm going to try to find my x-intercept first. Bless you. So at the x-intercept, the y-coordinate is
0.
So here's how we do this. I'm going to replace the y with a 0. By doing this, when I solve for x, I'll have my x-intercept. So the convenient thing about this is, what is anything times 0?
0.
0. So that effectively makes that second term just go away. So 2x equals 6. If I divide both sides by 2, if I were you, I would write it like this. X-intercept, 6 divided by 2 is 3. So using a similar method, why don't you guys find the y-intercept? This would be 2, oops. Could you guys stop with the little bubble sound? Thanks. 2 times 0 minus 3y equals 6. So to find the y-intercept, I plug a 0 in for x. So just the other way around, right? So, of course, anything times 0 is just 0. So you end up with negative 3y equals 6. You divide by negative 3, and you end up with a y-intercept of negative 2. Is that still making sense?
Yes.
Yeah? So now what we do is we just plot those 2 points. So the x-intercept was 3. So that means I'm right about here. And the y-intercept was negative 2. So that means we are right about here. And remember earlier, the way that we define a line is simply with 2 points. So I would attempt to connect those 2 lines, or those 2 points with a straight line. And remember, with lines, we put the arrows on the end indicating that the line goes on forever. And we're done. So what do you think? Graphing by intercepts, not bad, right? Pretty easy, because you plug in a 0, you get the x-intercept, you plug in a 0, you get the y-intercept, and you connect the dots with a line and you're done. So let's see if you guys can do that by yourselves with example number 3. Okay, you guys look like you are progressing pretty well, so let's go ahead and check our answers here. The principles are the same here. Guys, you ready to go? Good? So let me try to explain this to you. We can kind of compare our answers and see if we're all good. So my first goal is going to be to find the x-intercept. In order to find the x-intercept, I need to plug a 0 in for y. So it's going to look like this. 6x equals negative 8 times 0 plus 13. Of course, just like before, anything times 0 is 0. So it'd end up with 6x is equal to 13. Divide both sides by 6. And my x-intercept is approximately, let's say it'd be 2 and 1/6, right?
Yeah.
So we could say, you know, I'll do it like this. I'll say approximately 2.2. So, you know, if I were grading a quiz, I would see that 13 over 6 and realize, yeah, they definitely got it, right? they understand that it's 13.6 on a graph, approximately 2.2 maybe makes sense. So over here on the graph, I would put, so let's think about where this would make sense on a graph. What if I put my 2.2 right here? Does that make sense?
Yeah. No, it does not.
Aren't I off by about 1?
Yeah.
Didn't I put it at 3.2? Yeah, so that's not good. I know. So what if I put it right here?
No, that's 1.2, Mr.
So, thank you. So where would be the only okay location for this point?
In between 2 and 3.
Between 2 and 3. So I want you guys to know, like that would be okay right there. I'm not going to get out my ruler and say, wow, you were pretty close, but you were off by 1/10 of a millimeter.
Sorry.
So I'm sorry, you're not going to get credit for that. I'm not going to do that to you as long as with this, you're between 2 and 3. It's about the best you could hope for, isn't it?
Yeah.
So don't stress about being perfect on the graph right there. I get it. It's hard to graph decimals and fractions. We want to do our best. Okay, so the other one is a little bit tougher. Avery, if I'm trying to find the y-intercept, what do I do?
You would do 6 times 0 equals negative 8y plus 13.
Yeah, plug a 0 in for x. And so that what you said there is exactly what we would get. This might get a little bit weird, so let's be careful with this. 6 times 0, of course, is 0. 0 equals negative 8y plus 13. So what was that again, Ellie? That's right. We need to actually solve this. So subtracting 13, I end up with negative 13 is equal to negative 8y. And now it looks a little more normal, right? We divide by negative 8. And so I end up with a y-intercept of 13/8. And 13/8 is...
1 and 5/8.
It is 1 5/8, so it's 1.625, isn't it?
Yes, it is.
Okay, so maybe that helps a little bit on how to graph this, 1.625. So my y-intercept, let's see here. Well, my y-intercept would have to be located where? On the graph.
On the y-axis.
On the y-axis, yes, but between which two numbers?
Between 1 and 2.
It's got to be between 1 and 2. So if I just put it up here somewhere, that's pretty close, right? It's going to be hard to argue with that. So once I have that, I will attempt to connect those 2 points with a straight line, put the arrows on the end, and that would be my line. What do you guys think?
I like it.
Okay? Let me give you an opinion. You can take this or leave this. I know that you guys learned slope-intercept form in middle school at some point or another. I feel like that's everybody's bread and butter. You know, it's like this is what my go-to, like I can do this. I would tell you for problems like numbers 2 and 3, I think intercepts are easier and faster.
But when it comes to later on, wouldn't you want to use slope-intercept form?
You need to be flexible, I would say. I would want you to be able to use any form, not just one form. So please don't say, I'm only going to do slope-intercept, or I'm only going to do intercepts. There's other forms too. I would say be flexible and know them all. Be flexible to be able to do the best method given the situation. Okay, we're moving along. Something about skiing. You know a little bit about skiing. Okay. So, you've at least seen snowboarding or skiing on TV. Maybe you've done... You know what I'm talking about, right? Okay, listen carefully. Seriously, what I would say is a little on the silly side, but I think it'll be a good way for you to remember this. Let's start off with horizontal lines. All horizontal lines have a certain form, and let me put it to you in terms of skiing. How many of you that are skiers or snowboarders, like you enjoy doing that, how many of you would be excited about skiing a horizontal slope?
That'd be so sick.
Horizontal?
Right down.
How fast would you go on a horizontal slope? No, yeah, no miles per hour. So, hey, maybe
Butter on it, though.
if it's horizontal, you're still not going to go anywhere.
I know.
Good catwalks.
But you have to put effort into it. No fun.
I have one of those bungee.
I want gravity to do the work for me. So this is where we get it. Hey, guys. Hey, Evan, Alec, Ellie. Shh. That's your cue to stop. So a horizontal line, let's just be clear about this. A horizontal line looks like this, doesn't it? So here's, other than like you trying to like find ways to say yes, I would say that would not be much fun skiing or snowboarding for that matter, right? It's just a horizontal line. You're not going to go very fast. So listen, there's a point to this. I would say that all horizontal lines have the form of, why would I ski it? Why would I bother to ski it? Because I'm not going to go anywhere. So Listen, listen. Ellie, please. No. This is why I hesitate to give like creative analogies because then you start Googling T-bars.
I forgot what it was.
So I'm going to give you a chance just to like refocus.
I'm sorry, it was distracting.
Are we good?
Yes.
Okay. So all horizontal lines have this form right here. Y equals some number. Like y equals 2, y equals 3. We could just say y equals a, where a just stands for some number. So I would tell you the easy way to remember this is simply this. Think of it in terms of skiing. Why would I ski a horizontal line? So use the letter Y. Get it?
Yeah.
Y. So it's a play on the word WHY and the letter Y. Like, why would I ski it? So Y equals is a horizontal line. Now it gets better. I grew up being a skier. My first job out of college enabled me to ski like 50 or 60 times a season. And so I love to do steep stuff. But I must say that skiing a vertical line would be a little scary, right? So if you attempted to ski a vertical slope, you would get X'd out. Which is a cutesy way of saying probably dying.
Dead.
Yeah, probably dead. So all vertical lines have this form. X equals 5, X equals negative 12. Bottom line, X equals A, where A just stands for some constant. So a vertical line, if you tried to ski it, you would get X'd out. Horizontal line, why would I ski it? Who cares? That makes sense?
Yeah.
So please remember that a vertical line will always be X equals some number. A horizontal line will always be Y equals some number. And armed with that information, I think you could probably handle number 4. Number 4 says graph X equals 2. So automatically when you look at that, what kind of line is it? It's vertical, right? Because it's X equals. If it were Y equals, you would automatically know that it is a horizontal line, but this one says X equals, so it's automatically vertical. Let's see if you can locate it in the correct spot. All right, Hunter, did you draw your line in?
Yeah.
Where did you draw it?
Right. I'm lost.
Oh, you're lost. Okay, let's go back.
I did it right on the line.
Well, why do you say you're lost then if you drew something?
Well, I drew something, but I don't think it's right.
Where did you draw it? Right on which line?
Middle line.
Which
This up and down
the y-axis?
Yes.
Oh, gotcha. Okay, so that your feelings are good, and that is not correct.
Yeah. Should I graph it 2 over on the right?
Yes,
Up and down?
it's a vertical line. So the fact that it's just x equals, that makes it vertical,
All right.
and the location is 2. And so we would graph it over here at 2, so it'd be a vertical line over here at x equals 2. What do you think? Does that make sense, Ben?
Wait, so since Y isn't missing, we just like assume that it's 0?
No, we don't assume anything. There just is no y. We can get into the details here a little bit more if you want.
Kind of like 0.
No, there is no y. There just is no y at all. So I want you to think about it like this. This is essentially, if you want to go to this level of detail, that's fine. This is essentially telling you that the x-coordinate is 2, regardless of what the y-coordinate is. This is saying whatever y-coordinate you can think of, whether it's a negative number, a positive number, yeah, the x-coordinate will always be 2. If you think about plotting points here, like if you think about this point right here, this point would be 2, 3. This point down here would be 2, negative 4. So the y-coordinates are free to be whatever they want, as long as the x-coordinate is always 2. That guarantees a vertical line. Make sense? Okay, awesome. Sam?
So when you're like plotting a point, say it's like 3, 2,
Mhm.
is 3 your x?
Mm-hmm. So
Is that why we're going over 2 and not up 2?
Yep.
Because it's x, y.
It's always x, y. It goes in alphabetical order.
Oh,
Yep. Good question. Anybody else? Any other follow-up questions? Okay, well, let's go ahead and move on to the other one, number 5, which I think you'll find to be just a little bit different. So the hope with a problem like number 5 is you look at that and say, well, there's no x, it's simply y equals negative 5. That means that this is a very specific type of line. What would you say? Yes?
Horizontal.
Horizontal, that is correct. So, in other words, like the skiing thing, you look at this and there's only a Y. Why would you ski it? Because it's horizontal, you would probably question your sanity. Why would I bother skiing this thing? Maybe you wouldn't, but it is, as Ellie mentioned, a horizontal line. Now, the other key to this is, where is it located, right? It's not just any random horizontal line. It's located where?
Down 5.
Yeah, down 5. Yeah, so we'd go 1, 2, 3, 4, 5, and put a horizontal line right there. And we're good. So only Y means horizontal. Let me take you guys a little bit further. If only X means vertical and only Y means horizontal, what happens if you have a mix of X and Y?
Vertical and horizontal.
You've
It's just a diagonal.
It's angled, isn't it? It's angled somewhere. So, nobody in their right mind would ski a vertical slope, would they? And nobody with any ambition to go fast would ski a horizontal slope. But if there was an X and a Y, might you ski it?
Yeah.
Yes.
Going like that.
Because it would just do this, right? It would just be downhill, but not going to kill you, and not boring like a horizontal. It would just be some angled slope. Yeah.
There are people who ski.
Yeah, I know. This is where we're going a little bit too far with the analogy, okay?
Parachuters.
Yeah, I get it. Let's not go that far with the analogy. Okay.
Use a T-bar.
Yeah, the T-bar. That sounds like a lot of fun.
Oh, what?
Just ride the T-bar. We'll work on it and figure out what we're trying to figure out here. So, the graph below shows mileage data for a 2010 Prius hybrid. What information do the intercepts give about the car? Interesting. So you got that hopefully right in front of you. You can kind of read the graph. Let's point this out first of all. The intercepts are here and here, aren't they?
Yeah.
It's the y-intercept and the x-intercept. So, but what we're trying to figure out here is what do they actually mean for this Toyota Prius hybrid?
How many gallons of
Like
gas
the-
are you doing? Or how
Oh
many,
my gosh.
how much gas are you using for the number of miles?
Okay, well, so I think we can explain each intercept individually, right? So let me put it like this: what does the x-intercept mean?
Number of miles driven.
Be specific though. What is the x-intercept? The x-intercept is 600, and it is number of miles driven.
600 miles driven.
Okay, but isn't an intercept? Doesn't it have a coordinate point, like a coordinate pair, like x comma y?
I know.
So
When,
go ahead.
when 0 gallons of gas in the fuel tank remain, you've driven 600 miles.
Nicely said. We could say it backwards though too, couldn't we?
Yeah,
Like after you've driven how many miles?
600.
You have how much gas left?
0.
That makes sense? Well said. I'll write it the way you said it second. So when you've driven 600 miles, maybe we could put the tank has 0 gallons of gas. So that's from right here. Where do we get the 0 from, William? Like you get the 600, don't we?
Yeah.
Where do we get the 0 from?
Well, the 0, that basically means you don't have any more gas.
Yeah, because we're on the x-axis, right?
Yeah.
How high is the x-axis?
12 gallons. Oh, no, that's
Like when we're at the, it's 0 high when you're at the x-intercept. That's right. Another way to think about this is this. Think about the way that we graphed intercepts. To find the x-intercept, y has to be
0.
0. So if you're at that x-intercept, automatically the y is 0. Let's see if you guys can interpret the y-intercept. Please take a minute and write it down like I just did up here. Let's see what you get for an interpretation of that. Okay? So take a minute, write it down, get an answer or two from me in a second. The y-intercept, what do you think?
At 12 gallons left in the tank, you've driven 0 miles.
Yeah.
Oh my gosh, I'm so dumb.
At 12 gallons left in the tank, you've driven 0 miles. Doesn't that make sense? If you have a full tank, how many miles have you driven?
0.
None. If you've got an empty tank, apparently you've driven the maximum number of miles, which apparently is 600. Ben?
Does it matter if we put it like in order X, Y?
Well, in what context? Like 600 comma 0?
Like if we said at zero, when you've driven 0 miles, the tank is 12 gallons. Like, I know it doesn't change the meaning, but it doesn't matter since that's technically like X comma Y.
Oh, let me make sure I understand what you're saying. So you're saying like for the y-intercept, if you said, if you've driven 0 miles, you've still got 12 gallons in the tank? That's totally fine. Yeah, I'm not really concerned about the order. But if you're writing as an ordered pair, the ordering matters, right?
Yeah.
But if you're writing as an English interpretation, I think you're good. Yeah, I don't think there's any need to worry about order there. I know I would take either way, just because if you're correctly interpreting it, you're correctly interpreting it, right? Okay. Any other questions? Yeah, Sam.
Okay, this doesn't make sense because it says gallons of gasoline remaining, and then it says numbers of miles driven. So you drive 600 miles, but you still have 12 gallons of gas left.
No, you don't actually. So check this out. So this line that connects those 2 points, like this point right here, this point is 600, comma 0, right?
Like, yeah.
Right? Because whenever you're at the x-intercept, the y-coordinate is 0. So this is telling me right here that I have driven 600 miles, and my y-coordinate goes with the y-axis, doesn't it? So this means that I have 0 gallons left in the tank. This point right here, this other one, the other intercept, what that means is that I have, like the coordinate there would be 0, comma 12. That means that I have driven 0 miles, and I still have 12 gallons left in the tank. It's not saying that after you've driven 600 miles, you still have 12 gallons. We're talking about 2 separate points. One of them is you haven't driven at all and your tank is full. The other one is you've driven a lot and your tank is empty.
Okay.
Does that make sense? Okay. Ben.
So this would help us, because then we can see like the number of miles and how much gas they use. Like if we went 240, it would be like
How much is left? Right.
7 is okay.
240, yeah, about.
So that's why the line's there, so you can like see.
Yeah, it's just it's a linear relationship between number of miles driven and amount of gas left in the tank. Yep. So later on we'd look at the slope of this and it would tell us our MPG, miles per gallon. Yeah. Okay, great questions. All right, let's move on. We'll get as far as we can here. We'll probably come close to finishing this, but maybe not all the way. Okay, so this says the slope of a line is a ratio that compares, ratio means fraction, right? Compares what? Yes, well said. Rise over run, Amelia, you are correct. Compares the rise of the line with the run. It's always rise in the top and run in the bottom. So there's a couple of formulas associated with this, and I think we'll get to those a little bit later. But for now, rise and run, I think, are a good way to put this for how we're going to handle example number 1. So, example number 1 says, find the slope of the line graphed below. So the challenge here for you is to determine some points that are exactly on the line. So try that. Let's see if we can find a couple of points that are exactly on the line. I will try to do the same. Okay. I've got a couple of them. Let's compare notes here. So what I'm thinking is right here is exactly a point that is exactly on the line. I'll erase that. I'll do some other ones. Like I think this is exactly on the line.
Yeah.
That one look like it's exactly on the line to you?
Yes, it's exactly on 2 lines.
Yep. And then how about this one right here? That point exactly on the line? You guys with me? Does that make sense? So the truth is, as long as you pick points that are exactly on the line, it really does not matter which 2 points you choose. I'll try to illustrate that here in a second. Because you can always reduce, exactly. So what I'm going to do here is I'm trying to find my slope. And by the way, there's usually a letter that we use to represent slope. You remember what letter that is?
S.
M? Did I hear M? I heard F's and S's. Definitely never S. M. The letter M is what we usually use for slope. So I'll put this over here. M equals rise over run. So using those 2 points that I just drew up there, what is the rise between those 2 points? 2. I'll draw it in with a little triangle. Do you see how that is too long right there? Hello, hey. Do you see it? Yes or no?
Yes.
Okay. What is the run in between those? So the run would be the horizontal. 4. Okay, so I've got a rise of 2 and a run of 4. So I would say my rise is 2, my run is 4. So my slope is 2/4, which would reduce to be? Let's say, for instance, that I chose some different points. Check this out. What if I chose some points that are on the line, but let's say I chose this point right here and this point right here. So my rise would be 1, 2, 3, 4, 5, 6. And my run would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. True. So my rise over run would be a rise of 6, a run of 12, still reduces to be 1/2. So you see my point there? Like no matter how you draw the points, as long as you draw points that are actually on the line, you should get the exact same slope. Jake?
So couldn't you just make it easy on yourself and put the dots on the two closest?
Yeah, you get them as close as possible. Yeah, I agree. But I just wanted to point out that since the slope is constant, it really doesn't matter which 2 points I pick.
Okay.
Yeah, good question. All right, basic idea with slope. We good? Okay, fair enough. Let's move on. Rise over run, didn't you?
Yeah, that's why I'm kind of confused.
So let's talk about that. Let's talk about how this is the same thing. What is in the top here? We've got a y2 minus a y1. What does y address on a graph?
The rise thing.
Height, right? Doesn't height and rise kind of go together? So when I look at this right here, I think y2 minus y1, that really is rise. I'll prove it to you here in a second. And then run. Wasn't run horizontal? Which letter describes horizontal? See the run? Change in x. So there's other ways to write this. Did anybody see it maybe in middle school written like this? Delta y. Oh, let's do better with that. Delta y over delta x. What does delta stand for? Change in. Yeah, so the change in y is the rise. The change in x is the run. It's just using a little more technical symbols to describe this. So some other things here. Do you guys understand? I think this is a really crucial thing. This is not y squared, right? This is not x squared. What those are subscripts that are saying like it's the second x and the second y and the first y and the first x. And so please don't think of those as being squareds. If you can keep this formula straight, it really is a matter of plug and chug. So let's be very careful with it. We should be able to find success. So this is a formula that you can use for the problem like number 2. So here we go. Number 2 says, find the slope of the line that passes through -2, -5, and 4, 15. We're going to start off with our slope formula. So I'll write that down. M equals the second y minus the first y over the second x minus the first x.
Oh, so just do -2 minus 4.
Well, hang on, Rocky. Like you're onto a good thought there, but I want to give you just a little more structure. What I want to do, I've got 2 points, don't I? Do you see them up there? Yeah. With those points, like the -2, -5, is that x comma x? Is it y comma y? Is it y comma x? What is that point right there? XY. What about the other point? Also XY. So what I'm going to actually do here is I am going to arbitrarily assign my first point here to be my number 1 point, making my other point my number 2 point. Let's go through and label now. If the point on the left is my number 1, then I would say -2 is really my x1. And a -5 is my y1. Does that make sense from a structure standpoint? They're both xy. Since that's number 1, it would be x1, y1. So then, Alec, what is the -15? Yeah, the second y. Christiana, what is 4?
X2.
Yep, it's the second x. So x2. So once you have that straight, it really is a matter of being very careful with your positives and negatives, but just putting things where they belong. So here's what I would do with this one. x2, or excuse me, y2 is negative. Christiana, did you have a question? I'm sorry. You had your hand up.
No.
Okay. So y2 is negative 15.
Actually, I did have a question. I'm sorry.
Question.
Okay. Can I change them? I don't need to put it.
We'll talk about that in a second. We'll talk about that in 1 second. It's a good question. Okay, and then minus y1. Here's where there's some danger. Please watch. Minus negative 5, right?
So that's 5.
So it'll end up being plus. You're right. x2 is 4 minus x1 is negative 2. So once again, that'll end up being a plus when we finish this. Okay, so plus a positive, I end up with negative 15 plus 5, negative 10. 4 plus 2 is 6. So if I reduce this, I would end up with what? Negative 5/3. Yep. Christiana, you talked about ordering.
Yeah, and I did it the other way and I got the same answer.
Yep, you should. Let me show that real quick and see if all this makes sense. Didn't I randomly, arbitrarily choose the number 1 and the number 2? What if I decided to choose them differently? Here's how it would go. I would say, maybe I want this to be my number 2 and this to be my number 1. It really doesn't matter. I'd still get the same slope. So m equals, my y2 would now be negative 5 minus y1 would be negative 15. And then it would be negative 2 minus 4. So this is plus, so this would give me positive 10 in the top, negative 6 in the denominator, which is still negative 5/3. The lesson to be learned here, Christiana did it great. Lesson to be learned is the ordering really doesn't matter as long as you stay consistent. If you start flipping things around and being inconsistent, you're going to find out that the order really did matter. So pick your way, pick your order, and stay with it. Okay, questions? Okay, fair enough. We're rapidly coming to the end here. Let's see what we've got left. Can we use the ski thing again? So remember, with a vertical line, you know, it'd be pretty scary to ski, wouldn't it? Because you would get X'd out. You'd be dead. If you wanted to ski a horizontal slope, why would you ski it? Right? It doesn't make any sense. So can we continue on with that?
Yeah.
Okay, so here we go. The slope of the line x equals negative 4. First of all, what kind of a line is that?
Vertical.
It's vertical. Okay, I agree with you there. So, the slope of a vertical line, I'm going to tell you this right now, I'll prove it to you if you want. The slope of a vertical line is what we call undefined. So I'm going to give you another ski example here. If you tried to ski a vertical line, you'd be undefined. You'd be X'd out. You'd be undefined. You would not exist, right? So there is no slope there, right? What is this kind of a line over here? Y equals 3. No, I asked what kind of a line it is.
Horizontal.
It's horizontal, so let's think this through. With a horizontal line, what do you think the slope is? It's not that there's no slope, there is...
Undefined.
No?
No rise.
There's no rise. Well, the rise is 0, isn't it?
Yeah, so it'd be 0.
So the slope is
0 over 1.
just 0. It's just 0. So the slope is 0 for a horizontal line. The slope is undefined, or you could say doesn't exist for a vertical line. Here's why. If you think about rise over run, on a vertical line, what's the rise?
The Y. A lot. The Y.
Ooh, careful. How big is the rise? On a vertical line looks like this.
Oh, it's undefined.
Doesn't it go? No, doesn't a vertical line rise forever?
Rise
Infinity.
But what's the run?
0.
0,
So if the run is 0, doesn't that mean we're dividing by 0?
which is 0.
Into infinity.
You're not allowed to divide by 0. Dividing by 0 is undefined. You can have a 0 in the numerator, but you cannot have a 0 in the denominator. Tell me you're not Googling it.
No, I'm not. I was just
gonna divide by a zero.
A little trust here. I'm,
Error.
yeah.
Sign next to it.
So let's think about the other one. Horizontal lines, rise over run. What is the rise on a horizontal line? Use a number. 0. The rise is 0. What's the run? Doesn't it just run forever?
So then it's 0.
So 0 over something is 0. Something over 0 is undefined. Doesn't exist. Error. There you go.
Sign X error.
So it's also
Yep.
undefined?
Whoa, okay. So, hey guys, too much chit chat. You just said something about something being undefined.
So is it the slope of a horizontal line? Is the slope of a horizontal line also undefined?
No, the slope of a horizontal line is 0.
But
The slope of a vertical line does not exist or is undefined. And so listen, if you want kind of a help to remember that, think of if you tried to ski it. If you tried to ski a horizontal line, how fast would you go? 0. If you tried to ski a vertical line, what would happen to you? Wouldn't you be undefined at the bottom? As you land in the parking lot at the ski area, you'd be undefined? Yes? Get it? Ellie, does that help?
Yes.
Okay, good deal. All right, I think we got time for maybe riding in your parents' car, driving around, or whatever, and you're going in the mountains, you see a steep hill, and it says, caution, 7% grade for the next 2 miles.
Yeah.
You ever seen a sign like that? They're trying to tell you that there's a steep downhill and you want to be careful with your brakes. Yes? Mm-hmm. If you've never seen that, next time you're driving around in the mountains with your parents, maybe when you get your license driving around, pay attention. You'll see occasionally, hey, caution, 5% grade next 3 miles. It means you've got a somewhat steep hill coming up. So grade would be our first application of this. Here's how this works. Let's do an example. Just north of Valor, I got this off Google Maps, by the way. So as far as Google Maps is as accurate as that is, this is exactly accurate. So just north of Valor, University Boulevard rises 65 feet in a horizontal distance of 813 feet. What is the average grade on this part of University Boulevard? So we're going to use the rise and the run to help us with this. So rise over run. Danny, what's the rise?
The rise would be 65 feet.
Yep, it literally says rises, right? But what about the run?
813.
It is, right? Because it says horizontal distance, so that's a run. So what you would do is this. Get your calculators out. Hold on. Get your calculators out and do 65 divided by 813. 0.079. So
it's 7.
grade is always represented with a percent. You said, did you say 799? 795?
799507995.
Okay. So this would be approximately equal to, if we round it off to just a whole number, it would be equal to,
0.08. 8%.
it's always a percentage, so you'd say 8%. So that part of university, oh, where are you going? That part of university is 8% grade average. So guys, we covered a lot of territory. We'll continue to apply this when I see you on Thursday. Keep working on your web assignment.
I like this.
See you then.